there is a big problem with the algorithm, and the problem is this. So consider you have consider this graph. You have a very simple graph, two nodes, A and B. A points to B is the only link, right? So that's the only thing. So let's assume that we have our lambda is 0.8, again, for no good reason. What happens when we run PageRank on this very simple graph? So on the first iteration, what's going to be the PageRank of A? Well, we know that nobody points to A, right? There's no links going into A. So the PageRank of A at the first iteration is going to be 1 minus lambda divided by 2. I have two nodes in the graph, plus 0 contribution for lambda because nobody points to me. Right? What is that going to be? That's going to be 0.1, because 1 minus lambda is 0.2. You divide it by 2, you get 0.1. So that is the PageRank of A after iteration 1. Now, I'm going to claim that that is also going to be the PageRank of A for eternity, for as many iterations as you have. You see why? Yeah, nothing contributes to A, right? So it's always going to get the same number because nobody's pointing to it, right? So at the first iteration, you actually get your final value. That's going to be the PageRank of A for eternity. Okay, now look at node B. Node B at the second iteration. What's going to be its PageRank? So that's the contribution from the random hop. That's going to be 0.1. And that is the contribution that I get from A on the second iteration. Because that is the PageRank of A at the first iteration. That's what I'm going to use for my second iteration, 0.1 times lambda, which is 0.8. So you get 0.18, right? So the total PageRank for node B at the second iteration is 0.18. And I'm going to claim that this is going to stay like that forever. Is that obvious why? Right? Because B only depends on A, and A is not changing. We just said that A stays constant. So B is not going to change. A is not going to change. But look at what's happening. The total PageRank in the graph is now just the PageRank of A plus the PageRank of A, so that's 28%. And we said that PageRank has to add up to 100%. So the question is, where did 72% of the money gone? Where is it? Right? 72% of the PageRank is just evaporated. So the reason this is happening is that B is a sink node. It's a dead end. Once you get into B, there's no way to get out of B except using a random hop. So think about what happens when you're in B. When you're in B, this random surfer guy, he flips a coin. If the coin comes up tails, you take a random hop. And during a random hop, with probability 1 minus lambda, you share the current PageRank of the node. Right? So that's all good. So what happens if the coin comes up heads? And the thing is, in a sink node, nothing happens. Right? The PageRank is lost at this point. Okay? And that's not good. That's where the 72% has disappeared. So what you want to do is you want to fix it. So how do you fix it? A hack is to renormalize PageRank to sum to 1 after every update. Don't do this. It's a surprisingly common solution, but it's wrong. It ends up overestimating the PageRank for nodes with high inlinks and underestimating it for nodes with low inlinks. So the PageRanks that you get are not equivalent to what you would do if you did this properly. So what should you do? The algorithmic solution is you take the sink node and you say, well, okay, I have to go somewhere, so let's assume that a sink node is connected to everything equally well. So it's gonna spread its wealth regardless of whether the coin comes up heads or tails. And of course, if you try to do this directly, if you try to take every sink node and introduce an outlink to every other node in the graph, it's going to become ridiculously expensive because all of a sudden your graph, which is usually very sparse, will turn into a very dense graph. So whatever you run on it will be ridiculously slow. So the solution is to sort of do that, but don't do that explicitly. Do it implicitly, right? Change the formula, change the PageRank update to reflect that. So when you're at a sink node, we're going to pretend that a sync node is connected to every other node in the graph. So that's our initial update for node X, right? So with probability 1 minus lambda, I came from a random node, that was the random hop, and with probability lambda, I came from one of the nodes that are pointing to me. So the part that you add to this is, now there is a third way to end up at node X, and the third way is you take a random hop from one of the sync nodes, right? And when does this happen? It happens when you get a head. If I'm at a sync node and I get a head with probability lambda, then I'm going to take a random jump to the node X, right? So how likely am I going to end up in X? It's just 1 over n, because the sync node is connected to everything in the graph, right? And what is the chance that I was at one of those sync nodes? Well, that's just the PageRank of that sync node. And I add it up over all the sync nodes, Z, so all the nodes Z that point to the empty set, that don't have any outgoing links. Okay? So, does that make sense? Okay. Third way to get at the node is random hop from one of the sync nodes. And we have lots of sync nodes, so you add it up over them. And it only happens during the head. And now you can take this and you can play around with the math a little bit and restructure it. Basically take this term and join it with that term right there, right? So, and you end up with something like that. So how do you get that? Well, this n comes out and it's the same denominators there. And then this part, the summation over all the sync nodes of their PageRank, I'm going to call it S, right? So that is the total amount of PageRank that would have been lost in the sync nodes. That's the S, and it's one big constant, right? Because sync nodes connect to everything equally well, so you can just treat it as one big constant for all the nodes X, right? So that's what it says. S is the sum of PageRanks over the sync nodes. And that is a quantity, it doesn't stay constant, right? The amount of PageRank at the syncs is going to change from iteration to iteration. So you need to recompute it after each update, and it makes your algorithm just a tiny bit more complicated, but still really, really simple. Okay, so that's what you want to do. This will appropriately take care of the PageRank from sync nodes.